So our next section is going to be on double summations, and these are actually a little bit more complicated. The indexing is a little bit tricky to work with, but they do come up, and they're going to come up quite a lot inside of algorithms. So let's take a look at an example, and the example that we're going to use is going to be the sum, and we're going to be I equals 1 up to 4, and then we're going to take the sum of j equals 1 up to 3 of ij. Okay, so what you're going to notice is you've got two summations, right? And so we have to actually understand what this means, all right? So we're going to work from the inside out. So much like functions, you work from the inside out, so we're going to start with the inside. And unlike the single summations, where what you're doing is you're just, taking the value for j each and every time, what we've got to do is we've actually got to write out, in this case, we've got a couple of summations that we're going to write out. So we're going to substitute 1 in for j, and then 2 in for j, and 3 into j, but then that means that we're going to end up with a sum, I equals 1 up to 4 of, in this case, 1i. So that's when j equals 1 plus the sum I equals 1 up to 4 of 2i, that's for j equals 2, plus the sum I equals 1 up to 4 for 3i. So what you're going to notice is that we're actually going to iterate this summation. We're going to iterate the outer summation as many times as we actually have the inner summation. All right. And so now we're going to have to evaluate each one of them. I equals 1 up to 4 of I, all right, is going to be 1 plus 2 plus 3 plus 4 plus, and then now we're going to take 2 times I plus, so that's the first summation, plus 2 plus 4 plus 6 plus 8. That's the second summation. And then we have the third summation, which is going to be 3 plus 6 plus 9 plus 12. Okay? So you'll notice that what we've done now is we've taken that outer summation, right, with the new sequence that incorporates all of our values for j. So this one is 3 plus 3, that's 10, plus, and this is going to be 20, and this will be plus 30, okay, which equals 60. And there you go. Some cool stuff we can do with summations, actually, that might make this a little bit easier, is to notice that, say for example, notice how 10, okay, 20, and 30, they're related, right? 20 is 2 times 10, and 30 is 3 times 10, right? So if you kind of remember from your pre-calculus class, you might remember that if I have the sum, I equals 1 up to 4 of 2i, I can actually pull that scalar out of the summation, and then I can make it 2 times the sum I equals 1 up to 4 of I. Now I know what the summation of I is. The summation of I ends up being 10, so that means that this is just going to be 2 times 10. Ta-da! And that's 20. So it's kind of a cool little thing that you can do when you're working with your summations. Now let's take a look at another example. Let's look at another example of a double summation. So we're going to take the summation I equals 1 up to 3 times the summation of I equals 1, or j equals 1 up to 2 of I minus j. So again, we're going to do the inner summation first. All right, nice that there's not too many of them. And so this is going to end up equaling, right, the sum I equals 1 up to 3 of I minus 1 plus the sum I equals 1 up to 3 of I minus 2. Okay? Then we're just going to go out and evaluate each sum, right? So for this first sum, this guy right here, that's going to give me 1 minus 1 plus 2 minus 1 plus 3 minus 1. And then the second sum is going to be plus 1 minus 2 plus 2 minus 2 plus 3 minus 2. Okay? So we start with our inside, right? We evaluate that, plugging in basically our values for j for each one of the summations, and then we'll evaluate the sum in each term. So this will be 0 plus 1 plus 2 plus -1 plus 0 plus 1. That's going to end up giving me 3. And that's the value for my second summation. All right, so that's how a double sum works. Just remember, with a double sum, what you're going to do is you're going to evaluate, right, or basically plug in all the values for the terms for the inner summation, right, for the values in the outer summation. Okay, so that means that you're going to have basically however many summation, you're going to have however many values you have for the indexes, the lower limit and the upper limit. For the inner one, you're going to have that many summations of the outer summation. Okay, and that's how the double summation works.